Welcome to the basic concept simplified by committee. Today we introduce ourselves to the universal law of gravitation, and the question is, suppose we have two origins placed a distance apart. What is the force between the two origins? Okay, we can consider the first origin with mass 1 and the second origin with mass 2. They are both separated by a distance r measured from their centers, and then we connect the two using a spring balance and try to get the reading. And the reading will be 0 because there is no force between the two origins. To understand this one, we need to introduce ourselves to the universal law of gravitation. This law was first published by Newton in 1687. It is a statement that defines the attractive gravitational force between two planetary masses, M1 and M2, separated by a distance r. If we put it in form of a statement, every particle attracts every other particle in the universe with a force that is directly proportional to the product of the masses and inversely proportional to the square of the distance between them. If we put it in the form of a proportion, we get Fg is equals to, on the numerator we have the product of the two masses, on the denominator we get the square of the distance. If we replace the proportional sign with an equal sign, then we have to multiply with a certain constant g. We call it the universal constant, whose value is 6.674 exponential negative 11. That is Newton per square meter per square kg. Okay, to make the law very clear, we need to include that one of the masses must be the source of the gravitational pull, and therefore the law can only apply in a case of one origin and the planet. So we can have our origin, which gives us the first mass, and then the planet Earth to give us the second mass. We consider the distance between the two centers so that we get r, and then we can now apply the gravitational law to calculate the force between the planet and the origin. The force obtained will be equivalent to the one that will be measured using a spring balance. Okay, it is possible to measure the mass of the origin using a beam balance, but how do we measure the mass of the planet Earth? That is a concept for the next lesson.